Welcome you all. I am Dr. Raviraj, Professor and Head of the Department of Computer Science Engineering, Kalaignar Karunanidhi Institute of Technology, Coimbatore. I am very happy to deliver the lecture about the code optimization in compiler. What is code optimization inside the compiler? Actually, code optimization is one of the phases of compiler, which is present as the fifth phase of the compiler. The purpose of this code optimization is to optimize the coding, and it will improve the efficiency of compiler. That is why here we are saying that the optimization is mainly used to elimination of unnecessary instruction. That means the redundancy of data. It also improves the codings. It also improves the efficiency of compiler and faster sequence. There are two types of code optimizations here, that is local optimization and global optimizations. What are the main principal sources of optimization we have inside the compiler is? The main purpose of this optimization is it will reduce the complexity of the program, and it also improves the efficiency of the compiler through the effective optimizations. So with the help of this optimization, it will preserve the semantics that is logical of the original program. It doesn't affect the logic of the program. Without affecting the logic of the program, it preserves the meaning, and also it will improve the efficiency of the compiler. It also applies some concept for low-level semantic transformation, which is mentioned here. What are the different causes of optimization? Means mainly redundancy of data. The programmers may write a codings. At that time, they may have a repeated redundancy of data or functions in many places. For that, a lot of reasons we have. Redundant operations are at the source program, so it have some side effect while writing the program in high-level language. Sometimes we may expand the programs. We may expand the programs into number of low-level arithmetic operations. Sometimes the programmer may not aware about this particular programming, so that they may do the redundancy of data. This is one flowchart we have. It's a data flow diagram to explain the concept about various operations here. If you look at the diagram, we did so many arithmetic operations inside each and every block. This block 1, block 2, block 3, block 4, block 5 and block 6. A lot of calculations have been done inside this particular chart. So in this, with the help of this example, I am going to explain how the optimization has been taken place. The optimization takes place based on the different factors. That is, the compiler can improve your program without changing any functions, without changing the meaning of the program. There are four type of actions take place in optimizations. The first one is common sub-expression elimination. The second one is copy propagation. The third one is dead code eliminations. The fourth one is constant folding. First, what is common sub-expression eliminations means? Mostly, many of the programmers, they may call the same codings inside the program in many places. For example, if you look at this block 5 in the previous mentioned diagram, these are the codings we have. Here we can find T6 equal to 4 star I, similar way T7 is equal to 4 star I, similar way T8 is equal to 4 star J, T10 is equal to 4 star. So this 4-star I computations called in or the result has stored in two temporary variables T6 and T7. 4-star J will be stored in T8 and T10. This is called as redundancy of data because the same computational value has been stored in two different temporary variables. So these kind of common expressions will be eliminated during the time of code optimization techniques inside the compiler. After optimization, we come to know the block file, the next diagram, that is this one. Here we removed T7 and T10. We have only one value here. So this kind of common sub-expressions will be eliminated. Through that we will optimize the code. Through that we will improve the compiler efficiency. Previous optimization take place locally within this block. But now we are going to discuss about the global optimization between these two blocks inside the program. Here if you look at block 3, we have T4 is equal to 4-star here. Block 5, we have T8 is equal to 4-star here. So how it can be reduced means, here this 4-star J has been stored in T8. This T8 has been called here A of T8, that is A of 4-star J. So here we ultimately come to know, instead of this AT6, we just call T3 directly, because that is why here we call X is equal to T3, because T3 shows A of T2, T2 shows 4-star. So this kind of eliminations take place. This kind of eliminations is called as global optimizations. Then one more next type of method is copy propagations. So here if you look at A is equal to D plus E, B is equal to D plus E. So simply both values are same. Simply we call one more value and say these two values. Both will be integrated in this common sub expression. Here also the same. C is equal to T. Here T is equal to D plus E, A is equal to T. So B is equal to T, C is equal to simply T. This will be make it as simple here. Then the next factor is dead code eliminations. What is called dead code means? Dead code means some of the code we may call inside the program, but we will not use that particular code anywhere else inside the program. It is just simply present inside the program without no use. That is called as dead code. So that here we are mentioning that a variable is live at a point in a program if its value can be used subsequently. Suppose the value is not used anywhere else, that code is called as dead code. That kind of code will be eliminated during the time of optimization inside the compiler. Then one more factor is called as constant folding. That is, constant folding is we have to use some values. For example, pi. Pi means 3.4 or 22 by 7. So instead of using pi, we may directly use the particular constant value 3.14. This kind of optimization also can be done inside the compiler during the time of code optimization. Here this is called as dead code because there is no use of this particular X is equal to T3 in these both blocks, because without this we can derive this particular coding, so that it is called as dead code. We will eliminate this dead code. We will not affect the logical meaning of this particular program. The next one is code motion. This is also very important. This is particularly about loop optimizations. Inside the loop optimization, if you look at in this example, while we are calling here I is greater than or equal to limit -2. Just see here, inside that loop, we are calling some conditions. We are giving some expressions. But we have to avoid this kind of calculations inside that loop. So that here we just made it simple. Before, instead of this expression inside the loop, we just do the calculation outside the loop. Then we just simply compare this particular value here. So through this kind of loop optimization, the efficiency of compiler will be improved. The next one more thing is induction variable. Induction variable is also related to the loop iterations. It can be incremental or decremental using some values. So it can be computed with a single increment per loop iterations. So this kind of induction variable also we have to take care during the time of compilations. The next one is strength reduction. We are very particular about using the operations, arithmetic operations. Sometimes we may use some exponential operator. That kind of exponential operator we have to apply. For example, 5 square, the value is 25. Similar way, but here we are using exponential operator. Similar way, the same value we will get with the help of multiplication. Instead of 5 square, we may put 5 into 5. That is also a 25. But instead of exponential operator, if we use the multiplication operator without affecting the meaning of this particular program, that is called strength reduction. This technique also is very much useful during the time of compilation in code optimization technique. Here, if you look at this diagram, we are calling so many computation expressions inside each and every block. Here the loop iteration is the self loop. We have this block will be iterated. This loop will be iterated many times. But we have calculated so many expressions, arithmetic operations inside this particular blocks. This has been avoided with the help of optimizations. Here, if you compare the previous diagram and this diagram, here previous diagram we found this computation, but in this diagram we have avoided this particular computation inside the loop because we just compute that value before the block that is here. So outside the block we have calculated everything outside the loop. Then we just compare that loop here. Then the calculation will be made easy. This is the achievement of optimization inside the compiler. So I would like to conclude that code optimization plays a major role inside the compiler design. That is the fifth phase of the compiler because this helps the compiler to run that program or to compile the program in an effective way. It also reduce the compilation time. So code optimization is one of the main role inside the compiler design. Thank you to all. Thank you.